Hello, I'm Brian Farrell, and welcome to PACE IT's session on coaxial and fiber optic network media. Today I'm going to be talking about coaxial network media and fiber optic network media. We have a bunch of material to cover, so let's dive right in. And we'll begin by talking about coaxial network media. Now, coax is one of the oldest Ethernet cabling standards. It has been used for baseband, that's carrying a single digital signal. It's been used for broadband, carrying multiple digital signals. A coax cable is composed of a central conductor that is covered by an insulating layer, which is covered by an outer metal mesh that is finished off with an outer insulating layer. The inner metal mesh or foil layer helps to protect against electromagnetic interference. Now, coaxial cabling requires that the ends of the cable be terminated by some kind of resistor in order to keep the signal from bouncing back down the cable. The value of the resistance required is measured in ohms and is called the impedance value. There are two impedance standards used with coax. There's the 50 ohm and the 75 ohm. In most cases, the equipment that's attached to the end of the coax has the resistor built into it, but not always. You need to know that if you're working with coaxial cabling. Now let's talk about coax cable specifications. Coax is broken out into different categories based on its physical characteristics, such as the size of the conductor, the size and composition of the inner insulation layer, and the impedance value. These specifications are detailed in the radio guide tables. Now, the RG tables were a specification developed by the U.S. military. They no longer use it, but we still use the RG specifications to talk about coax. Now, what are some common coax standards? Well, there's RG58. It is used for 10 megabits per second networking. That's 10 base 2 networking. Now, it can span up to 185 meters, and it has an impedance value of 50 ohms. Then there's RG8. It was used for 10 megabits per second networking as well, only that was 10 base 5 networking. It could span a distance of up to 500 meters, and it too had a 50 ohms impedance value. RG11 was also used for 10 base 5 networking, and it too could span up to 500 meters and had a 50 ohms impedance. Last up, we have what you'll find in most cases, which is RG6. Now, it's used for cable television or broadband. The distance that RG6 can span varies, but it has an impedance value of 75 ohms. You will still find RG6 used today. Now let's move on to fiber optic network media. So let's talk about fiber optic cabling. Now, fiber optic cabling is composed of small, very clear glass or plastic tubing that is coated with an outer covering that's called cladding. Network traffic is carried by a light beam that is transmitted down these fibers. The source of the light is either an LED or a laser diode. Fiber is a high bandwidth media carrier. That means it can carry a lot of data, and it's capable of carrying that data over large distances without the use of a repeater. Fiber optic network media is not affected by electromagnetic interference and is a lot harder to intercept mid-transmission than other types of media. But fiber optic cabling is relatively expensive and harder to work with than other types of network media, with the end result being that it's not used very often in the local area network, but can often be found in the wide area network environment. In most networking applications, if you're going to use fiber optic cabling, you need to use two. One cable to transmit data and one cable to receive it. Fiber optic cabling is usually categorized by its transmission style and its core size, as well as the size and type of cladding that it uses. So let's talk about those fiber optic classifications. The first thing that you need to know is that fiber optic cables are classified initially by their types of transmission. And those types of transmission are multimode fiber, MMF, which uses an LED as the method of transmitting the light down the cable. And then there's single mode fiber, SMF. It uses a laser diode as the method of transmitting light down the cable. Now, these fiber optic cables are subclassified even further based on the size of their core and the thickness of the cladding, both of which are measured in micrometers. So what are some common subclassifications? Well, for MMF, there's 50/125. Then there's 62.5/125. The classification for single mode fiber typically varies with the core size, and it has core sizes ranging from 8 to 10.5 micrometers, and it usually comes with 125 micrometer cladding. So let's talk about the difference between MMF and SMF. Now, MMF uses an infrared LED system to transmit the light signal. It sends multiple rays of light down the fiber. MMF is used for shorter runs. You cannot exceed 2 kilometers. It is less expensive to implement than single mode fiber. And the most common application in networking utilizes MMF 62.5/125 cables. And the maximum span that those can run is 275 meters. Now let's talk about single mode fiber. It uses a laser diode arrangement to transmit the light signal, and it sends a single ray of light down the fiber. The advantage of single mode fiber is that it can be used for longer runs. It can traverse up to 40 kilometers without using a repeater. So now let's talk about some common fiber standards. There's 1000 base SX. That's 1 gigabit per second networking, and that runs on multi-mode fiber up to 500 meters. We also have 1000 base LX, 1 gigabits per second networking on single mode fiber up to 5 kilometers. Then there's 10G base SR. That's 10 gigabits per second networking on multi-mode fiber up to 300 meters, and it uses a local area network type connector. There's also 10G base SW, 10 gigabits per second networking on multi-mode fiber, and it can span up to 300 meters, but it uses a wide area network type connector. Then there's 10G base LR, 10 gigabits per second networking on single mode fiber. It can span up to 10 kilometers, and oddly enough, it comes with a local area network type connector on the end of it. Then there's 10G base LW. That's 10 gigabits per second networking on single mode fiber, and it can span up to 10 kilometers and uses a wide area network type connector. And then there's 10G base ER, 10 gigabits per second networking on single mode fiber up to 40 kilometers with a LAN connector. And finally, there's 10G base EW. That's 10 gigabits per second networking on single mode fiber spanning up to 40 kilometers using a wide area network connector on the ends of it. Now, something to keep in mind is that if the standard has an S in it, as in SX, SR, SW, those are multi-mode fiber. The S stands for short. If it has an L in it, as in LX, LR, LW, that's single mode fiber of up to 10 kilometers. And finally, if it has an E in it, ER, EW, that stands for extended. And that's single mode fiber of up to 40 kilometers. Now that concludes this session on coaxial and fiber optic network media. I talked about coax network media, and we discussed fiber optic network media. Now, on behalf of PACE IT, thank you for watching this session, and I look forward to doing another one soon.